Today we are going to look at partial differential equations. A partial differential equation describes the relationship between a function of two or more independent variables and at least one of the partial derivatives of the functions. In our example, we want to verify that the function u of x, y, t is a solution to the partial differential equation u sub tt equals 4 times the quantity u sub xx plus u sub yy. Alternately, we can read this as the second derivative of u with respect to t equals 4 times the sum of the second derivative of u with respect to x and the second derivative of u with respect to y. To show that u of xyt is a solution to the given equation, we need to find the three second derivatives, substitute them into the equation, and then check for equality. We'll start by calculating utt, the second derivative of u with respect to t. The only portion of u that is dependent on t is cosine of 20 pi t. The derivative of cosine is negative sine, so we replace cosine 20 pi t with negative 20 pi sine 20 pi t. We can simplify this by moving negative 20 pi to the front and multiplying it by 10, giving us the derivative with respect to t of negative 200 pi times sine of the quantity 6 pi x times sine of the quantity 8 pi y times sine 20 pi t. Taking the derivative again and moving 20 pi to the front, we find that the second derivative of u with respect to t is negative 4,000 pi squared times sine of the quantity 6 pi x times sine of the quantity 8 pi y times cosine 20 pi t. uxx comes next in the given equations, so let's find it now. Once again, the only thing in u that depends on x is a single trigonometric function. The derivative of sine of 6 pi x equals 6 pi times cosine of 6 pi x. We can simplify this by multiplying 10 by 6 pi, giving us 60 pi cosine of the quantity 6 pi x times sine of the quantity 8 pi y times cosine 20 pi t. Taking the second derivative of this equation, we get 60 pi times the quantity negative 6 pi times sine of the quantity 6 pi x times sine of the quantity 8 pi y times cosine 20 pi t. We can now simplify this if we gather the constants at the front of the expression as negative 360 pi squared. So far, we've calculated utt and uxx. Uyy is found in exactly the same way as uxx. Notice that, like x, y is inside a sine function. Uyy is equal to negative 640 pi squared times sine of the quantity 6 pi x times sine of the quantity 8 pi y times cosine 20 pi t. Now that we have all of our second derivatives, let's substitute them into the equation and check that the equality holds. We know what utt is, so we need to find 4 times the sum of uxx and uyy. Let's start by finding the sum. Looking at uxx and uyy, we see several common factors. Negative pi squared, sine 6 pi x, sine 8 pi y, and cosine 20 pi t. So by the distributive property, we can factor this out of both uxx and uyy, leaving the quantity 360 plus 640. Adding inside the parentheses gives 1000. Multiply both sides of the equation by 4, and rearrange the terms on the right to show that 4 times the quantity u sub xx plus u sub yy equals negative 4,000 pi squared times sine of the quantity 6 pi x times sine of the quantity 8 pi y times cosine 20 pi t. This is equal to UTT. UTT and u of xyz as a solution to UTT equals 4 times the quantity uxx plus uyy.